Hello everyone, welcome back to CodeMaster. In today's video, we will break down the insertion sort algorithm step by step. We will cover what insertion sort is, how the algorithm works, a Python implementation, dry run examples, time complexity analysis, and real-world applications. By the end of this video, you will be able to confidentially write and explain insertion sort yourself. Let's get started. Insertion sort is a simple sorting algorithm. It works the same way we sort playing cards in our hands. We start with the second element and compare it with the elements before it. If it's smaller, we shift the larger elements to the right and insert the current element in the correct position. This process repeats until the entire array is sorted. Let's break down the algorithm step by step. The first step, we start with the second element, treat the first element as already sorted. In the second step, we compare the current element with previous elements. We check if the current element is smaller than the elements in the sorted section. In the third step, we will shift the elements larger than the current elements one position to the right, which means we will move the elements that are larger than the current element one position to the right. In the fourth step, we will insert the current element at its correct position, which means we will place it in the correct position. In the fifth step, we will repeat for all elements. We will continue until all elements are sorted. Let's make this clearer with an example. Suppose we have the array 12, 11, 13, 5 and 6 as elements. In the past one, we will compare 11 and 12. Then we will insert 11 before 12. So the result will be 11, 12, 13, 5 and 6. In the past two, we will compare 13 with previous elements. There will be no change since 13 is larger than 11 and 12. In past 3, we will compare 5 with 13, 12 and 11. We will shift elements and place 5. So while comparing with 11, 12 and 13, 5 is smaller. So we will shift the element 5 to the first place. In the past 4, we will compare 6 with the previous elements and insert 6 in the second position, since 6 is smaller than 11, 12 and 13. Now that we understand the logic, let's implement this in Python. This is the Python code for insertion sort. Mainly, first we loop through the array starting from index 1. Then for each element, we compare it with the elements in the sorted section. After that, we shift the elements to make space. Then insert the current element in the correct position. Let's do a dry run of the code. Initial array is 12, 11, 13, 5 and 6. In the first iteration, we will compare 11 and 12. We will swap 11 and the result will be 11, 12, 13, 5 and 6. In the iteration 2, we will compare 13 with 11 and 12, and since 13 is larger than 11 and 12, no swap is needed. In the third iteration, we will compare 5 with 11, 12 and 13. Since 5 is smaller, we will shift the elements and place 5 in the first place. In the iteration 4, we will insert 6 in the second position, since while comparing 6 with the previous elements, 6 is smaller than 11, 12 and 13. This is how insertion sort works step by step. In the best case, it is order of n. In the worst case, it is order of n square. And also in average case, it is order of n square. And the space complexity is order of 1. For small or nearly sorted arrays, insertion sort is very fast. But for large random arrays, the quadratic time complexity makes it slower. These are some of the advantages and disadvantages of insertion sort. First one is simple to understand and implement, no extra memory required, and it is a stable sort, which means it maintains relative order of equal elements. Some of the disadvantages are it is inefficient for larger data sets, quadratic time complexity in the average and worst case, which means it have high time complexity for unsorted data. So when to use insertion sort? So it is best for small data sets and almost sorted arrays, and when stability is required. And it is not suitable for larger unsorted data sets and time sensitive applications with larger inputs. Some real world applications include online sorting, when elements arrive one by one, for example in the live leaderboards, small data tasks, sorting small arrays or linked lists, teaching and learning. It is great for learning how sorting algorithms works. To summarize what we have learned today, insertion sort is a simple but powerful algorithm for small or nearly sorted datasets. It helps understand fundamental concepts like element comparisons and shifting. While not the most efficient for larger inputs, it's a valuable learning tool. In the next video, we will be comparing all the sorting algorithms we learned so far. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe to CodeMaster for more coding tutorials. Stay tuned for the next video and happy code.